Hey, what is going on, guys? Welcome to another episode of the Diggly Dig Math Do. I don't know what that was, I actually just made that up. But welcome. So I believe this is our second Algebra 2 video. And in this video, we're going to be covering how to deal with square terms in equations. And when solving equations, what do we do when faced with a very frightening square term? I know we may not know how to deal with them, we may not have been told how to deal with them before, but after this video we're going to pick up the skill to handle any square, and I repeat, any square in a equation with a square. Right? So one more thing on that, this is a very versatile skill. We're going to see it in a few different examples, but realize you can use this whenever you're solving equations. Whenever you're solving equations. Right? You see a square in there, you're going to do these steps, and then you're going to be able to get rid of that square. Right? Like, just take a second to realize the plethora of equations you're now going to be able to handle. Right? The now incredible things which you'll be able to model and solve for and just mathematically computate. Right? Like NASA level stuff, like when they're dealing with quadratics, you can now solve these. Without the quadratic equation, of course. It's cheating if you don't know how to solve it, if you don't know how to derive it, by the way. So, okay, let's go ahead and get started. So solving one variable equations with a square term in it simply requires undoing the square term with a square root operation, right? These are inverse operations. We got that inverse operation board. We know that when we turn a power, or when we turn a square, it undoes it with a root, or a square root, right? So the opposite of that square is our square root. So we're going to use that to get rid of it. It's very key. So this is done using usual reverse PEMDAS order when solving. Thus, the square must be isolated before taking the square root. Okay, so basically what this is just saying, that we can solve this the way we do everything else, right? We're just going to go backwards. We're going to, first get rid of our subtraction because we see that first. Then we're going to keep on going up PEMDAS. If we have multiplication, we'll get rid of that. We don't have multiplication, so we keep going up. Then we see an exponent, and that's when we start to deal with our exponents with these roots, with this new root skill that we're going to acquire. Okay? So we're just going to do this in typical order, and what this basically means is that before we take the square root of this, to get rid of it, it has to be isolated. If it's not isolated, you're going to get some weird stuff going on. You're going to get numbers that are trapped under the square root, and it's just going to be beyond my mathematical knowledge to computate. Alright, so it's really important that we isolate that first because it's going to keep this simple and streamlined. So let's go ahead and start that reverse PEMDAS. So I'm going to get rid of this minus 3 right here, and I'm going to add it to both sides, right? So we'll have y plus 3 equals x minus 1 squared. Cool. So now we are ready to do our square root operation. Oh, and my bad. I totally forgot about this. Oh, what's happened? I lost focus here. So if you look there, it says, there we go, that when y is equal to 1, right? And so this is actually fine what I did, but I just want to make sure to plug in that 1 for y. That's going to help me out a little bit, right? So I'll go ahead and do that now. I'll just circle this and draw an arrow over to it so it's very clear. And then 1 plus 3 equals x minus 1. Okay. And before I go on with this, I'm just going to do a little bit of simplification. Right? I see the 1 plus 3, and I know that's 4. And so I'm just going to simplify that and rewrite the other side of the equation. Cool. Now we're ready to do our square root. Right? And so the second part of this is we need to take a little bit of special care when doing the square root. And the reason why is because with a square term, right, with a square term, we're multiplying two of the same thing by each other, we can put in two different numbers. We can put in a positive version of a number and a negative version of a number and get out only a positive, right? We can have two inputs going to one output. So we got to remember that when undoing it, right? We're working with the output, so we're going back to the input, which means we're going to have to account for two different solutions, right? One of which is a positive, one of which is a negative. And some of you guys may be making connections to our absolute value equation, and that's absolutely a great connection. The only difference here is we actually have to do the square root operation before we can kind of make that split in positive and negative. Okay? So let's go ahead and take our square root. We're going to do it just by drawing the square root sign over everything on both sides, right? Everything has to be wrapped up in it. Nothing can escape it. It is a monster. It is devouring. It eats everything. It's actually a helpful monster. It helps us solve these equations. So what we're going to get is, so before I do this, normally this is the place where I would go ahead and break this off into two equations, kind of like our absolute value equations. One of which would have a positive, one of which would have a negative, and then we'd have two equations, we'd solve both equations, and ta-da, we get our solution, right? There's actually a notation that can save us a little bit of writing space. It's the same idea, exact same idea, but it just saves us a little bit of space when we're writing. And it's called plus or minus, right? Literally, we just write plus or minus. Mathematicians, thank goodness for keeping it simple, or at least as simple as they can. What you're going to do is you're just going to write plus or minus in front of the thing you want to make plus or minus. Now with this, it doesn't matter which side you put it on, and I encourage you to investigate why that is. But just for doing this, you can just take me at that and understand that it doesn't matter which side I put it on. Right, so the square root of 4 is 2. I have my plus or minus there, which is signifying, hey, I can have a negative 2 inside of there that was plugged in, or I can have a positive 2 inside of there, because either way it's going to become positive, right? It doesn't matter. And then the square root of my x minus 1 squared, well, that square root's going to get rid of the square. And that was the whole point of this. Right, so we have x minus 1. Okay. Now, we're just going to go ahead, we're going to keep on going up PEMDAS, and the only thing to do now is our minus 1. So we want to get rid of a minus 1 by adding 1 to both sides. Okay? And so, with the plus or minus sign, you can just write it just right in front of the plus or minus sign. In a way, you can kind of treat that plus or minus sign like a single operation, right? Like if it was just a plus right there, or if it was just a minus right there. Right? It's not a single operation. It is two. It's plus and minus. But the way we write it is just the same way we would write any other operation. Right? So what we get out of here is x equals 1 plus or minus 2. Okay? So let's go ahead and let's write out both solutions for that, right? So this works, and you can turn that in, right? You can box this, and this is fine and dandy. That gets you full points. That expresses both solutions. But if we want to make this maybe a little more explicit, we can calculate this, right? So we can calculate the 1 plus 2, and we can write that there, and we can calculate the 1 minus 2, and then write that there. Okay, so the 1 plus 2 is going to be 3, and the 1 minus 2 is going to be negative 1. Right? And now, I have a graph over here, and let's see how this makes sense on our graph. Okay? So remember, the start of this problem was that we were looking for x when y equaled 1. Okay, so we're going to go onto our graph, and we're going to go to y equals 1, right? It's right about there. Okay, so now I'm wondering, what is my x value at about that point? Okay, so I see if I go over here when y is equal to 1, I have an x value of negative 1. And I see when I go over here to my other y value, right? Remember, we can have two of them. It's got some symmetry going on. I can have x equal to 3. And that makes sense, right? We have x can equal 3, or it can equal negative 1. Ergo, Q, E, D. We actually wouldn't write that for this, but that's what you do in higher level fancy math courses. It actually means what we set out to prove is that which is proved. I know, very logically progressive statement, but it's just what you write after a proof. But so that's our answer. Okay, we solved it. We were given an equation, and we ultimately only had one thing to solve for, right? That y, sure, it wasn't there, but it was there, and we plugged it in. We substituted it, so we got rid of it, and we had one variable left over, and then we went and we solved it using our new square root operation. Okay, that's our first example, right? And so that's the more thorough of the two. I'm going to kind of put this one on fast mode, right? I'm going to go with a little less explanation between each step. But the same ideas are going to apply, same ideas. Nothing is changing aside from our equation, right? Okay, so same thing, we're looking for x when y is equal to this. Ultimately, what we're dealing with is a one variable equation because we're given 4, so now we just need to find what x is. We need to find our x. We did not get over him or her. We are still longing for them. I'm sorry, that's like the lowest hanging math joke you can make. Okay, so we are going to add 4 to both sides, right? Just to get rid of that minus 4. Remember, doing backwards PEMDAS. Alright, so that goes away. 4 plus 4 is going to be 8 equals 2 times x minus 1 squared. Alright, now cool. Now you may be tempted to do the square root operation, but wait, we have a 2 that's multiplying this, right? Backwards PEMDAS tells us we got to get rid of that, and we also know that if we do the square root of that, it's not going to be very clean. We can handle that, but it's not gonna be as nice. We're gonna get a 2 trapped under there. So let's go ahead and first divide both sides by 2. Right, dividing everything by 2. 8 divided by 2 is going to be 4, and 2 divided by 2, well, that just cancels, leaving us with x minus 1. Alright? We are ready to apply our brand new operation, our brand new math tool, which is saving the day, which is getting us brilliant math scores, which is making us little geniuses. Okay? So we're going to take the square root of both sides. And side note, some people actually like to write the plus or minus right outside the square root. It helps them remember everything, and it's actually mathematically more correct. Right? Because as soon as we take the square root, we realize, oh dang, there can be a plus and minus here. Right? So then we're going to calculate that square root. That's going to be plus or minus 2. This is going to be the square root of x minus 1 squared. Sorry, brain fart. Those two are going to cancel, and x minus 1 is what we get over there. Cool. So I'll draw an arrow up to right there, and then we're just going to add 1 to both sides. I'll even write it over here just so it's a little more visually congruent. Plus 1, plus 1. So that'll be 1 plus or minus. Remember, 2 operations going on there is equal to x. Okay. Right, that works. You can turn that in. That is beautiful. That is an excellent solution. Or you can go ahead and go that extra mile and do 1 plus 2. So x can equal 1 plus 2 is 3. Or x can equal 1 minus 2, which is negative 1. That is super weird. Not going to lie, I did not plan on that. Both of these equations have the same solutions. Did not plan on that at all. Weird. Okay, notice that's definitely a coincidence. That it's not like, oh, they're all going to be x equals 3 and negative 1. You will fail so fast. Okay. So that's basically it, right? That, like, for the most part, that's our skill. But now let's go ahead and look at a more abstract application of it, right? So taking in some of our previous skills, we can find the inverse equation by using the same method of switching the x and y and then solving for y, right? Remember, we learned a skill that allows us to now solve for square things. So solving for square things isn't a problem, and so if we have to do it with an inverse, that's okay. We're just going to now use that new skill on top of our old skill. Right? So let's go ahead. F of x. We know we're doing the inverse equations. We know, hey, we can treat that like y. We know that the higher level mathematicians are like squealing and like, no, they are not the same. But you know what? We're at a lower level course, so go away. The nice way of putting it. We can switch x and y, right? And that's how we take the inverse. So let's go ahead and switch x and y. Cool, so this is the inverse right here, right? We switched our x's with our y's, but of course now we have to solve it again for y. And we got a square term in there, but we are not afraid, right? God, I was actually about to start singing like Eminem or something. Anyways, right, we're not afraid because we know how to get rid of this. It's a square term, and we just learned how to get rid of a square term. So let's go ahead, doing the algebras. We got x plus 4 equals 2 times y minus 1 squared. We have a 2 outside. We don't want to take the square root until we get rid of everything. The addition, subtraction, multiplication, division. So I'm going to get rid of the multiplication of 2 dividing by 2. And the x plus 4 dividing by 2. And I know you guys out there are fraction freaks, and you love to just separate the denominator, but I'm actually going to encourage you to keep it all together. We don't want to keep it separated in this situation. Right? I know the song tells us to keep it separated, but not in this situation. Okay, so let's go ahead, and now we can finally take our square root operation, because we are not afraid. And I'm going to go ahead and put that plus or minus over here. Side note, like I said, you can put it on either one, but the reason why I put it over here is because I'm solving for y. I want this junk alone, so I don't want to put a plus or minus on it. But you can, it's equally true to put it on either side. Cool, so, oh man, I know you guys are probably just like, whoa, what is this? You know, I have never solved math before like this, written it. I mean, look at that. The square root of x plus 4 divided by 2. Is that not just some messy stuff? That's okay. You're actually going to realize this is the easiest way to work with it because you don't have to calculate numbers. Right? You don't need a calculator when you do it like this. And pro tip, you can earn full points like this. You don't have to calculate anything and you can get 100. Like, you can, no joke, you're getting a snapshot at Mr. Zoyas in college, roll out of bed, turn up to the exam, no calculator in hand because you just rolled out of bed, get to the exam, ace the heck out of it, and then go back home and go back to bed, right? That's the beautiful thing about notation like this, we don't have to calculate it, okay? So, now we are going to do that final step, x minus 4 square root of x plus 4, and you know, I know it's uncomfortable to write big and weird things like that, but the more you do it, the easier it's gonna get, right? The more you're just gonna be like, oh yeah, no, I've seen that before, we just do it. Yeah, we deal with that. Yeah, it's okay. So we're gonna have 1 plus or minus the square root of x plus 4. Okay, and that is it, right? That is our inverse. 2 more points I want to make before we go on. So you can and you will be asked a question like this, right? What is the inverse of f of x for, I don't know, let's go ahead and say negative 4, right? You're going to be asked questions like that. I put it on your homework. What that's just saying is, right, we got our inverse function right there, right? Our inverse function, we can now write it like this. So let's go ahead and put these skills together, because I know you know how to do this. Right? Now this question is just saying, hey, what is negative 4 of the inverse function equal to? F of negative 4 of the inverse. So we're just going to plug in negative 4 2 here, just like we would any other function, right? Sure, it's an inverse, but we treat it just like another function. All functions are equal, right? We believe in equality. So negative 4 plus 4 divided by 2. Right? We plug in that negative 4 because that's where x was. And that's how we could evaluate that inverse function at negative 4. Right? And then just doing that math real quick. Negative 4 plus 4, well, that's 0. 0 divided by 2, well, that's still 0. Square root of 0, well, that's still 0. 0 plus 1 is just 1. Right? 0 plus or minus 1 is just going to be 1. Okay? And so our inverse at negative 4 would be just 1. Side note, the reason why it's only one solution right there is because we actually are at the vertex. Right? I don't know if you guys realized it, but we went to the vertex at that point. That's why there's only one solution. Right? The vertex is the one exception to when we have only one solution. Okay. Now, very last point, you can go ahead and leave if you want to, but very last shipping point, or very last point that I'm going to ship you off, it's just, I think this is so interesting to note. So we have y equals plus or minus, right? There's this plus or minus, and what that really means is we have two equations. So let's go ahead and go over here and look at this, right? This is saying we have y equals plus, right, the positive version of it, x plus 4 divided by 2 plus 1, and the negative version of it, minus x plus 4 divided by 2 plus 1, right? We have two equations. We found the inverse and we got two equations. I know that may be a little bit mind-boggling, but if anything, it makes sense when we logically break it down, right? When we undo a square, we're going to have two parts to it. And think about it. Normally, when we see the square, we only see one of these two lines, right? You see how one's green and one's red? We're used to seeing it only like that, right? Just like that. And it's got that kind of curve to it. But the truth is, when we find this inverse, there's actually two equations which are needed to make that complete inverse, right? You see how this whole thing is an inverse of this whole thing. However, we have two parts right here. Our green part right there, which is our positive version of this, and our red part, which is our negative of it. Both of these come together to make our complete inverse.